application of the dimensional analysis, students. Let's do one more application of dimensional analysis, students. In this application, we'll find the relation between different physical quantities, students. Or indirectly, we can say, we can derive the formulas. If you know in a formula which physical quantities are involved, by considering those physical quantities, we can derive one expression. Such a question is written on the board, students. What he's saying, deriving an expression for the centripetal force F acting on a particle of mass small m moving with a velocity v in a circle of radius r. Okay, students. Maybe most of you are familiar with the centripetal force. We call it as the center-seeking force. When it develops, when a body is rotating in a circular path, okay, it is rotating in a circular path. I'm not saying revolving. It is rotating in a circular path. Here, a force will act which tries to take that body towards the center. That is known as the centripetal force. And the centripetal force depends upon the three factors I said. One is the mass of the body, and second is the velocity with which it is revolving, and third is the radius. Okay, by using these three parameters, we have to derive an expression. Okay, students, it is small. I'm taking it as small. Let's do the solution. I said in a circle, if the particle is rotating or a body is rotating, a force will develop. Okay, let's say it is the mass moving with the velocity of v bar. Here it is a revolving radius. A force will generate. It works towards the center. We call it as the centripetal force. You must remember that the particle has to move in anti-clockwise direction. Okay, students. If it is the anti-clockwise direction, then what will happen? Every time the angle will increase. Let's say these physical quantities are related like this. Say force is proportional to. We are taking three physical quantities. One is the m, second is the velocity, and third is the radius. If you write a dimensional formula, all the time we'll get the powers to the physical quantities. Let's say m to the power of a, b to the power of b, and r to the power of c. Okay, students. Now we are writing the dimensional formula of force. You know that force is equal to m1 L1 T inverse 2. Okay, students. And also for the mass, the dimensional formula is m1 L0 T0. For the velocity, it is m0 L1 T inverse. For the radius, that's the distance, m0 L1 T0. Okay, students, these are the things what we need. Right now, I'm writing the values here. Is the V and it is the R. Here we got a relation. F is proportional to m to the power of a, v to the power of b, and t to the power of c. Okay, students. R to the power of c. R to the power of c, students. Okay, students. Then see, we know the dimensional formula of force, mass, velocity, and also radius. I'm rewriting the same here. I'm writing force is proportional. In the place of proportional, I am writing it is the K, proportionate constant. M, mass. What is the dimensional formula of mass? It is m1 L0 T0 to the power of m. And for velocity, it is m0 L1 t to the power of inverse power b. For the radius, it is the length, students, m0 L1 t0 to the power of 0. Further, it can be written as f is equal to k of m to the power of a l to the power of 0 t to the power of 0 multiplied with m to the power of 0 l to the power of b t to the power of minus b. And third, m0 l to the power of c and t to the power of 0. Okay, further it can be written as k of, we are taking the same physical quantities. If the bases are same, we have to add the powers. M to the power of a plus 0 plus 0, okay, into L to the power of 0 plus b plus c and t to the power of 0 minus b plus 0. And finally we get k of m to the power of a l to the power of b plus c and t to the power of minus b. Okay, students, up to here we did everything. Now we are comparing this equation with the equation of the, what's that, dimension formula of the force. As you know that dimensional formula of the force is m1 L1 t inverse 2 is equal to k of m to the power of a l to the power of b plus c and t to the power of minus b. We are comparing the power, students. You can write a as 1, b plus c is equal to 1 and minus b is equal to minus 2. Okay, students. Then we got minus minus get cancel, and finally we had b is equal to 2. Okay, we had the values of a, b plus c and b. Okay, we have to get the value of the c. Substituting this b in this one, b plus c is equal to 1 and b is 2, 2 plus c is equal to 1, c is equal to 1 minus 2, it is minus 1. Okay, students, and we had a as 1, b as 2 and c as minus 1. Now we are substituting all these values in the given relation, this one. Okay, we have to write it as f is proportional to m to the power of a, means m to the power of a means 1, and second is b to the power of b, b is equal to 2. Okay, students, and r to the power of c, c is equal to minus 1. Or you can write f is proportional to m to the power of 1, v square by r. Okay, students, m to the power of 1 is m is proportional to mv square by r, or f is equal to k into mv square by r. K is taken as 1. Then centripetal force has a dimensional formula of mv square by r. Okay, in this way you can derive a dimensional formula, derive a formula by using the dimension analysis. Okay, students, it is one of the applications of dimensional analysis. If you know the physical quantities which are involved in, okay, any formula, then you can derive the formula easily. Okay, students. Let's do one more relation, students. Here in this question, he asked us we have to derive this expression. That means what? Frequency is equal to 1 by 2L into root of f by time. Okay. And these words have their usual meaning, students. Nu is frequency. Nu is what? Frequency. What is frequency? You have to understand, students. Frequency is nothing but number of vibrations made by a body in 1 second. Number of vibrations made by a body in 1 second. But generally we can write it as reciprocal of time period. Reciprocal of time period. That is frequency nu is equal to 1 by t. And its unit is what? 1 by second, means second inverse. Okay, students, it is a frequency. Then second is said depends upon the load. Load means force. The second one is load, that is force. As you know that dimensional formula of force, and you know that force is equal to ma, or the dimensional formula can be written as m1 L1 T inverse 2. Okay, students. And one more physical quantity is involved. That is length of the spring. That is length of the spring. Length of spring is L. Okay. And dimensional formula of length is equal to m0 L1 T0. And one more thing is involved here. Is that mass per unit length. Mass per unit length is known as linear density, students. Mass per unit length is known as linear density. Linear density means what? Linear density is mass upon unit length. Okay, students, if you say linear density is x, it is mass per length, and the dimensional formula, okay, students, is equal to m1 L inverse T0. Okay, students, here we have the dimensional formula of linear density is this. Okay, I'm taking linear density as small. That's why we use the m here. Then the relation can be written as frequency is directly proportional to. First term, I'm taking force to the power of a. The second term, I'm taking length to the power of b. And third is the linear density. Linear density, remember that, m to the power of c. Okay, students. Then it can be written as frequency is directly proportional to. I'm writing the dimensional formula of force. What is that? m1 L1 t to the power of minus 2 to the power of a length. Directly I'm writing a to the power of b. And linear density we have m1 L inverse T0 to the power of c. Okay, students, then it can be written as n is proportional to m to the power of a, L to the power of b, t to the power of minus 2a multiplied with length to the power of b and m to the power of c, L to the power of minus c and t to the power of 0. When the bases are same, we have to add the powers. Frequency is directly proportional to m to the power of a plus c, L to the power of b minus c and t to the power of minus 2a. Okay, students. Here we learn that frequency is reciprocal of the time, and its dimensional formula of frequency is equal to T inverse. T inverse. Further, we are writing this as nu is proportional to m to the power of 1 means m to the power of a, L to the power of a, t to the power of minus 2a into L to the power of b multiplied with m to the power of c, L to the power of minus C. I'm neglecting the T. Then M to the power of A plus C. L to the power of A plus B minus C. T to the power of minus 2. Okay, students. But frequency here is T to the power of minus 1. That means you can write M to the power of 0, L to the power of 0, T inverse. Then after we have to compare the powers of these physical quantities. From this we can write A plus C is equal to 0. Okay, then A plus B minus C, A plus B minus C is equal to 0, and minus 1 minus 2A is equal to minus 1. Okay, and it can be written as 2A is equal to 1 and A is equal to 1 by 2. We had the value of A is equal to 1 by 2. Here I am substituting. A plus C is equal to 0. In this one, A is equal to 1 by 2 plus 3 is equal to 0, and C is equal to 1 by 2. That is minus 1 by 2. Similarly, if you substitute all this in this one, you will get B value. That is A plus B minus C is equal to 0. It gives you A is equal to how much? 1 by 2. Okay, B is equal to, we have to find, and C is equal to minus half. C is equal to minus half. That is minus of minus 1 by 2 is equal to 0. And finally we get 1 by 2 plus B plus half is equal to 0, and B is equal to 1. And we can write the powers as A. Okay, students, we had A is equal to 1 by 2. Okay, C is equal to minus 1 by 2. And we need to find the value of the D. Here we got B plus 1 is equal to 0, and B is equal to minus 1. Okay, students, now we have to substitute all this in this relation. That is, nu is proportional to F force to the power of half. Okay, students, L to the power of minus 1 and M has a power of minus half. Okay, students, and it can be written as F is proportional L inverse into F to the power of half by M to the power of half. I brought it down. Then it can be written as nu is proportional to L inverse can be written as 1 by L. Okay, students, 1 by L I am writing in the root F by M. Okay, students, if you take the proportionate constant as 1 by 2 and we yield the equation 1 by 2L into root of T by M. It is the actual form of the equation. Here force, he said force is the load. This load is known as tension, students. Tension is also a force. That's why finally we got the equation. Frequency of a vibrating string is 1 by 2L into root of T by M. I hope you understood this problem.